Okay, so today we're going to be solving question 32 from the SAT number 9 reading, and let's jump right into it. So question 32 says, which data presented in the table would McKinnon find most useful to his argument? So before we could solve this question, even if we've read the passage, even if we understand McKinnon's argument, the first thing we have to do is go back to the text and try to identify very specifically where McKinnon's argument is. So the way we can do that is you can just start to scan the text and just look for the name McKinnon because that stands out pretty well. And we find it here in lines 11. And then what we have to do is sort of go on to read and identify what his argument is. And pretty much his argument is entirely in this paragraph here. And what we want to do now is just sort of detail all the different aspects of it because we're not sure in advance which part the question is going to highlight. So we want to make sure we know all the points that McKinnon is making here. So I would say the first thing to note that he says Ceres is by far the largest object in the asteroid belt, right? It's not quoted directly to him, but it goes on to say, and that's not the only reason it doesn't quite fit, according to William McKinnon. So I'd say if we still include this as one of his claims, it's not the largest object in the asteroid belt. Next thing he says is that Ceres has a low density, right? Which suggests it's made up of water. That's a high proportion for an asteroid, but closely matches Pluto and other icy objects. So it has a low density, and that matches Pluto and other icy objects native to the outer solar system. And the last is that a dip in Ceres light spectrum may be a sign of ammonium-rich clay at the surface. So here we have three claims that he makes. One is it's by far the largest object in the asteroid belt. Two, it has a low density. And three, it has ammonium-rich clay. Okay, look at these horrible numbers here. Beautiful, beautiful. Okay, so now we can go back to the questions. And what we're going to do is we're going to look for an answer choice that's going to hit one of those three aspects of his argument. So let's go through them. Here's the table here as well, which we actually don't need a reference for this question, but you can look at it here. So A says the average density of Pluto is similar to that of Ceres. So this would relate to the second point that we noted, which is that McKinnon points out that Ceres has a low density and then compares it to Pluto and other icy objects. So this answer choice actually looks pretty good, and we should keep it in this case. B says Neptune is located much farther from the sun than is Ceres. At this point, I wouldn't even bother thinking too much about this answer choice. In the text that we found about McKinnon's argument, nothing is mentioned about distance from the sun. Nothing's mentioned about the relative distance for Neptune and Ceres. So this is one that we can definitely eliminate. Next says the mass of Ceres is only slightly greater than that of Juno. Now, we can make a case that this sort of refers to the first point that McKinnon makes, that Ceres is by far the largest object in the asteroid belt. We know that Juno is an object in the asteroid belt because of this here. It says that it's an asteroid. And so maybe this could work because it's saying that, like his points here, Ceres is by far the largest object in the asteroid belt. So for now, I'd say we can keep it and come back to it. Last one is Ceres is denser on average than either Neptune or Uranus. Now this might refer to, again, here, right, when McKinnon makes a point about the density of Ceres. However, D is making the wrong case. D is saying that Ceres is denser than either Neptune or Uranus, whereas the point McKinnon makes is that Ceres is less dense than some of the other objects that you expect to see in the asteroid belt. And it doesn't compare them to Neptune or Uranus, so we can eliminate this option here. So that really leaves us with A or C. So A says the average density of Pluto is similar to that of Ceres, and C says the mass of Ceres is only slightly greater than that of Juno. So what you want to do is you want to choose the strongest option. And the way we can do that is by kind of starting to focus on errors, right? Ask ourselves, what could be wrong? What's too specific? What's too general? What's making an assumption that's unjustifiable? And I think if we think about it enough, we actually should land on the fact that C has two issues wrong with it. One is that it conflates mass and size. So we told that Ceres is the largest object in the asteroid belt, but here in answer choice C, it's saying that the mass of Ceres is greater than that of Juno. And mass and size are not necessarily the same thing, although they're related. So that's one issue with it. The second issue is that it's sort of putting emphasis on this only slightly greater aspect, right? Whereas the point McKinnon makes is that it's by far the largest object in the asteroid belt. C is sort of in an underwhelming way, saying that the mass of Ceres is only slightly greater than that of Juno. So for that reason, you can eliminate this option and answer choice C, A, excuse me, is our correct answer.